Why don't we trust atoms? Because they make up everything. But in the world of quantum computing, they're actually our best friends. Quantum computers aren't just a small step forward. They're a giant quantum leap from the computers we're familiar with today. Imagine this, instead of bits, which are like tiny switches that can only be on or off, quantum computers use quantum bits, or qubits. These qubits are like magical coins that can be both heads and tails at the same time. This strange ability is thanks to a principle in quantum mechanics known as superposition. Now, I know what you're thinking. How can a coin be both heads and tails at the same time? Well, in the quantum world, things don't have to make sense in the way we're used to. In fact, it's a place where the impossible becomes possible. Let's think about it this way. Picture flipping a coin. The moment it's in the air, before it lands, we can't say for certain whether it will be heads or tails. It's in a superposition of states. It's only when we catch it, look at it, that it chooses to be one or the other. Now imagine millions of these coins flipping at the same time. The number of possible outcomes is mind-bogglingly large, and that's the power of quantum computing. Each qubit can hold an enormous amount of information, and the more qubits we string together, the more powerful our quantum computer becomes. Superposition isn't just about being two things at once. It's about blurring the lines between what we think is possible and what actually is. It's about taking that coin, flipping it into the air, and instead of waiting for it to land, being able to use all the potential outcomes at once. Superposition, it's like being in two places at once. Imagine the possibilities. Speaking of being in two places at once, ever heard of entanglement? It's like the Romeo and Juliet of quantum mechanics, but with less drama. Imagine your best friend moves to the other side of the world. It's a bummer, right? Now imagine that despite being thousands of miles apart, the moment you stub your toe, your friend simultaneously feels the same pain. An instant shared sensation, regardless of the distance. That's quantum entanglement for you, minus the toe stubbing, of course. In the world of tiny particles, this isn't just a wild idea, it's reality. Two particles can form a bond so strong that they become entwined or entangled. No matter how far apart they are, a change in one instantaneously affects the other. It's like they're emotionally connected, just like best friends, but on a subatomic level. It's this phenomenon that makes quantum computers incredibly efficient, as they can process multiple outcomes simultaneously. Talk about teamwork. So, quantum entanglement, the ultimate long-distance relationship. Now let's talk about quantum gates. No, they're not what Bill Gates uses in his garden. Quantum gates are fundamental to quantum computing. They're like the hinges on a door, allowing it to swing open or closed. Only in this case, the door is a quantum bit, or qubit. Picture a game of tic-tac-toe. Each move you make is like a quantum gate operation, changing the state of the game. In quantum computing, these gates alter the state of a qubit, just like your move changes the state of the tic-tac-toe board. But here's the kicker. In our tic-tac-toe game, you can only make one move at a time. In the quantum world, thanks to superposition, a qubit can exist in multiple states at once. So, it's like playing countless games of tic-tac-toe simultaneously. Mind-boggling, right? This ability to manipulate qubits is what makes quantum computers exponentially more powerful than ordinary computers. Quantum gates, opening doors to a new world, one qubit at a time. Ever heard the joke about the quantum magician? He pulls rabbits out of a hat, but sometimes the rabbit isn't there, or it's two rabbits, or it's a hat wearing a rabbit. Now, let's dive into the magic of quantum mechanics. Quantum parallelism, for instance, is like having a team of chefs working on different dishes simultaneously, rather than one chef, tackling each dish one by one. It's the ultimate multitasking, and quantum computers are the Gordon Ramsays of computing. Next up is quantum measurement. Think of it as a surprise party. You know there's a party, but you don't know when. The moment you walk in and everyone yells, "Surprise!" is the act of measurement. You've just collapsed the quantum state from perhaps a party to definitely a party. And quantum interference? Imagine you're at a concert, and two musicians are playing the same note. The sounds can combine to make a louder note or cancel each other out. That's interference. But with quantum bits, or qubits. Now, quantum decoherence is like trying to walk a group of hyperactive puppies. At first, they all walk together, but soon they start going their own ways. In quantum computing, we want to keep our qubits in line, just like those puppies. Quantum error correction? It's like autocorrect on your phone, but instead of fixing typos, it fixes errors in the quantum state. Sometimes it can be as embarrassing as autocorrect, but it's essential for reliable quantum computing. And the quantum circuit? It's the playground where all these quantum bits play together. They swing on the gates, slide down the circuits, and generally have a quantum fun time. Lastly, the quantum Fourier transform. It's like a prism that takes white light and splits it into its component colors, but for quantum states. it's a crucial tool for quantum algorithms. Quantum computing. It's not magic, but it might as well be. Thanks for joining us on this quantum journey. For more quantum adventures, subscribe and hit the bell icon for future deep dives. Like, share, and comment your burning quantum questions. See you on the next one.